Welcome to the session number 41 from the playlist of JEE Main Physics Part 2. The topic for the today's session is the current measurement in the case of static equilibrium, and the chapter is the magnetic effect of current. And based on this topic, I have selected one question for this session, which was asked in the IIT-JEE Main examination in the year 2015. So here the question is that there are two thin wires of length L, and they are held by insulating threads. They are in static equilibrium as shown in this figure. The mass per unit length of the wire is lambda. The current in each wire is I. So we have to find the value of the current in each thread if the threads are making an angle theta with the vertical. So this is the figure which was already provided with the question. So since these two thin wires are in static equilibrium and they are held by insulating threads, and in such a way that the wires are making an angle theta with the vertical. So here what I have done is I have already now this arrow is giving us the direction of the tension. The tension in the wire, the direction of the tension on the wire is indicated by this arrow. Now the tension here is taken as T. So I have resolved this tension into two components. One is the vertical component and one is the horizontal component. The horizontal component is equal to T sin theta and the vertical component is T cos theta. Now this T cos theta will balance the weight of this wire. Now here the mass per unit length of the wire is lambda. The length of the wire is L. So the mass of this wire will be equal to lambda L. So T cos theta will be equal to M into G. So this is the first equation. Now T sin theta will be equal to the magnetic force in the case of static equilibrium. Now here the magnetic force, the formula for the magnetic force in case of the two wires in which the current is flowing and they are separated by a certain distance, say d. So the magnetic force between the two wires carrying current and separated by a certain distance, say d, then in that case the magnetic force is given by mu naught upon 2 pi into the magnitude of the current in each wire, which is equal to, so in this case the current in each wire is I, so this will be equal to I into I, which will be equal to I square multiplied by the length of the wire divided by the separation between the two wires. So in this case the separation will be equal to, see here this is the angle theta, so this horizontal distance will be equal to L sin theta and this horizontal distance will also be equal to L sin theta. So this will be equal to 2L sin theta. So the magnetic force, the value of the magnetic force will be equal to mu naught I square into L divided by this 2 pi into 2L sin theta. Now if I divide now, so T sin theta will be equal to this value. So T sin theta is equal to mu naught I square L divided by 4 pi L sin theta. And T cos theta is equal to lambda Lg. So T cos theta here is equal to lambda Lg. Now if I divide both these two equations, then I will be getting T sin theta divided by T cos theta will be equal to tan theta and tan theta. And if I divide the terms on the right side of this equation, so I will be getting mu naught I square L divided by 4 pi L sin theta into lambda Lg. So from here this L and L will get cancelled out, and from this equation I am getting the value of I square as I square will be equal to tan theta into 4 pi into sin theta into lambda L G divided by mu naught. 4 pi I square will be equal to tan theta into 4 pi into sin theta into lambda L G divided by mu naught. So from here I can write this equation as tan theta can be written as sin theta upon cos theta. So this will be equal to sin theta sin square theta into 4 pi into lambda into L upon G divided by cos theta into mu naught. So I will be equal to sin theta, the under root of sin square theta will be sin theta, and here it is written 4 pi. So under root of 4 will be equal to 2. So sin and the rest of the terms will be taken in square root. So this will be equal to pi lambda L G divided by mu naught cos theta. So this is the value of I. So the current which is flowing in each of these wire will be equal to 2 sin theta under root of pi lambda L G divided by mu naught cos theta. So here the most important thing which we have to remember is the means we have to resolve the tension into two components. The one component will be balancing the weight and the other component will be balancing the magnetic force between the two wires. So thank you very much for joining this session. In the next session, I will be coming up with a different topic from the same chapter, that is magnetic effect of current. So till then, have a nice day. Bye.